Has this ever happened to you? Can't wait to go somewhere. Alright, let's head out. First, let me check. It's dead! Now how am I gonna be able to see where I'm going? Dang it. To solve this problem, which plagues millions worldwide, I'm going to make a solar-powered battery charger. Alright, so we've got a package delivered, fresh from Jeff Bezos. Probably, actually, I'm gonna need to blur that out. And this is gonna have the thing that's gonna help make this project possible. Now these are solar cells, and they're basically just tiny solar panels. And here they are. Now look at that thing. That's gonna give so much power. Let me just check that real quick. Yep, look at that. 5 volts, that should be perfect. Now we'll need to make some sort of protection circuit, as well as, actually, let me just give you a plan right now. You see this right there? That is a burn mark from my table from when I exploded a lithium-ion battery from just charging it improperly. So in order to prevent that from happening on my bike, and probably, you know, being pretty unsafe, especially because we're using 18650s, which are a lot bigger than the other ones I was using before, we're going to need to be more careful. Now, fortunately, I do not have to make an entire protection circuit because the flashlight probably, hopefully, they better already come with a protection circuit. So all we have to do is keep feeding it a consistent 5 volts. Now, the thing about solar panels is they kind of vary. So what I'm going to do is I'm just going to have a TL431, which is basically just a Zener diode, hooks it up so that it always outputs a constant 5 volts. So we're not really going to have a real protection circuit, but hopefully the flashlight can do most of the work for us. Alright. Also, in case you didn't notice, I am laying on the floor. So, this right here is the flashlight I use on my bike. It is currently dead, and this is the way you charge it, with a little micro USB plug. So, what I do not have is a micro USB cable on me right now, but I know I have one around because I've been using this thing. What I do have is a bunch of USB-C female connectors, and in there and right there I have a micro USB-C cable, and the one in there particularly is small and useless, so I'm going to sacrifice it for this project. So what I'm going to need to do is replace this port right here with this one, and this thing doesn't have any screws or anything, and there's only one way I can think of getting into this thing. Okay, so went back out there. Oh, I cut this off. This still wouldn't come off, so you can already see it, but I popped the lens off, and now it comes off cleanly. There was no reason to make this difficult to disassemble. I don't know how but I just now realized that the way they were supposed to go was that this all stays together. You just take the lens off, and then the whole thing just slides out. Alright, so now we've got our solar panel hooked up very expertly to the USB-C cable. I mean, it's not like I was going to use this thing for anything. It's incredibly short. Like, look at this. That is a very dissatisfying length. Okay, so something I wanted to show you was why we can't just do this. This is dangerous and bad because of the nature of solar panels. So let me just set this up. Now we've got this set up, let's check the voltage of the solar panel, because it's right now it's at 0, 0. Check this. Alright, so now it's alternating from 6 volts to 5 volts to 4 volts, probably because of the way I'm holding it on, but we need it to be a steady 5 volts, and right now this is not steady, nor is it 5 volts. Why is it 0 volts? That's weird. There you go. See, it's alternating a lot, which is unsafe for the battery. You definitely want to be safe with something this big. And it's got, like, warning labels all over it. So, we're going to need to make some sort of safety circuit to turn this wobbly 6 to 4 volts signal into a steady 5 volts. And I've got just the thing for it. Alright. So I did some research, and this is the circuit. You can't really see it very well here. I'm just shining a light on it. There you go. There's the circuit. Here's the actual diagram of it. So, here's the idea. Here's the solar panel. It is the power supply, and here's it also in real life. Now, the important part, or the two important parts of this circuit are this zener and this, it's not really a zener, but it acts like a zener. It's an IC. This is a MOSFET. It is what controls whether or not this battery charges. So the way it works is you connect the solar panel to the battery, which can go from anywhere really up to 4.2 volts. Its maximum operating voltage is 4.2 volts. And that's when it's fully charged. So normally it's going to be charging through this diode right here, which actually isn't really necessary. You don't need it. But it's going to be charging this battery. So, and then once, okay, so it's going to be charging this battery. Now, the solar panel normally has a voltage of around 5 volts, but once it's connected to the battery, it's going to drop down to, I mean, whatever the battery's at, could be like at 3 volts. Although that's actually really bad. Remember, that'd be under discharged, so probably around 3.6. So it's going to drop down to that and then slowly rise with the battery. And then once it reaches 4.2 volts, which is the threshold voltage for the zener, it's going to conduct and power along this line right here into the gate of this MOSFET, which is normally pulled down through this 100K, oh, messed that up, 100K ohm resistor. And then after that happens, it's going to conduct. The panel is no longer going to be charging the battery. Is going to be going through this LED, which is green to show that it's done, and this load right here, which doesn't really matter. It's actually just a resistor in this case. If you look again, it's that pink one right there, if you can see it. I'll zoom in on it or something. Anyway, so now that we've got it, it's only missing the battery, which is right here. Also, by the way, I broke this, so now it's just always on. So I'll probably need to fix that. So now what we need to do is to put it on this. Okay, so hopefully you guys weren't taking notes right here, because this is wrong. CO431s don't let current flow through them like a zener diode. So I'm switching up I didn't even draw it. Okay, I'm switching up the circuit into a different way, so I'll have to rewire this, so I guess we'll do that again. And now we're back. Alright, so after printing this out and messing around with it until this fit in there perfectly, I noticed a problem where when I put this on, the only place it would fit is like right here, and that covers this button. That's a problem because I intend on still using this thing after making this modification. So then I realized, along with the plug, I should make it so that I can just take this thing off whenever I need to. And so I thought of the idea of Velcro. So from the top, as well as actually on the bike, it doesn't look too bad and it works, but, set that down on purpose. From the bottom,
oh my god, bro. Oh, hell no, man. What the fuck, man? Get your ass on, boy.
So what happened here was that my bike was in the back of the truck, and the wind, I think, blew the solar panel clean off, broke the solder joints, and now it is just somewhere on that freeway. So I rebuilt it from scratch, except for the 3D print. I kept a 3D print, but I rebuilt the circuit, reattached a new solar panel, because I had an extra. If you look right there, I have an extra. So I rebuilt it, and here it is. And it's done.